We are often interested in knowing how far off a vector is from a specified direction. Quantities called directional cosines and directional angles, or just direction cosines and direction angles, are often used to describe this amount when the specified directions are the coordinate axes. Let's define these quantities. The angles a non-zero vector v equals a, b, c makes with each of the coordinate axes, or equivalently, with the unit vectors I, j, and k, are called the direction angles for the vector. They are named alpha, beta, and gamma respectively. The cosines for these angles are called the direction cosines. The direction cosines are found using the formula for the cosine of the angle between two vectors, with one of the vectors being the vector v, and the other vector being one of the unit vectors I, j, or k. Here are the formulas for the direction cosines. Each direction cosine is found by dividing the dot product of v and the corresponding unit vector I, j, or k by the product of the magnitudes of v and of the unit vector. You should notice that in each case the dot product in the numerator simplifies to just the component of v in the direction of the corresponding unit vector. Of course, to find the direction angles alpha, beta, and gamma, we use the arc cosine function with the direction cosines. In this problem, we are given a vector v and are asked to find the direction cosines and direction angles. In other words, we need to find the cosines of the angles and the angles themselves that v makes with each of the coordinate axes. We'll find the direction cosine for the angle alpha that the vector v makes with the x-axis first. We do this by finding the dot product of v with I, and dividing that result by the product of the magnitudes of v and of I. This means we are finding the dot product of the vector 1, negative 2, 4 with the vector 1, 0, 0, and then dividing by the product of the square root of the sum of 1 squared, the quantity negative 2 squared, and 4 squared, and the square root of 1. This simplifies to 1 divided by the square root of 21, which is the first of the direction cosines. We find the corresponding direction angle alpha by taking the arc cosine of 1 divided by the square root of 21, which gives us alpha equals 1.35 radians. We'll find the direction cosine for the angle beta that the vector v makes with the y-axis next, following a similar procedure. This time the numerator is the dot product of the vector 1, negative 2, 4 with the vector 0, 1, 0. The denominator remains unchanged. The result is negative 2 divided by the square root of 21 and the second of the direction cosines. We find the corresponding direction angle beta by taking the arc cosine of that result, which gives us beta equals 2.02 radians. Finally, we will find the direction cosine for the angle gamma that the vector v makes with the z-axis, again following a similar procedure. This time the numerator is the dot product of the vector 1, negative 2, 4 with the vector 0, 0, 1. The denominator remains unchanged. The result is 4 divided by the square root of 21, and the last of the direction cosines. We find the corresponding direction angle gamma by taking the arc cosine of that result, which gives us gamma equals 0.51 radians.